Hello everyone, welcome to Chemazon-Complete Chemistry. In today's video, we are going to solve some of the more remaining questions of the part B. Okay, that is a part 2 of the part B section. I've already made one video. If you have not watched, you can watch that. I have provided the link in the description. And these are some of the questions that we are going to solve. Let us see the first question. The correct set of possible term symbols for the electronic configuration. So electronic configuration given is 1s2, 2s1 and 2p1. So we are interested in the valence electronic configuration, that is this. Now 2s, that is it has one electron, and 2p has one electron. So for finding out the possible term symbols, we have to find out the possible values of L, possible values of S, and possible values of S is what? S is the possible values of, first we find out the total spin, and then what we have to find out the possible values of Sm, that is spin multiplicity. Okay, and the value of J. What is the general form of the term symbol? It is spin multiplicity, then the ground state term, and then the value of J. Okay, so what is the formula for finding out the value of L? Let us find out there are two orbitals, that is one is S and another is P. So value of, for S, the magnetic quantum number is 0. For this it is +1, 0, -1. Okay, so the two values of L are, L1 is, let's say, 0 for this S orbital, and other value is L2 is +1. And how do you calculate the possible values of capital L? It will be L1 minus L2 mod 2 mod of L1 plus L2. Okay, this I can write it as 0 minus 1 to 0 plus 1. So 0 minus 1 is -1. Mod means you have to remove the negative sign. So 1 to 1. So L value can only be 1. Okay, so if I write down the L value and the ground state term, if the L value is 0, ground state term is S. If it is 1, then it is P. If it is 2, then it is D. If it is 3, then it is F, and so on. So we want that the ground state term is only P. Okay, no other term. So check the options. Okay, if you see the options, here there is S. Here there is S. So option 1 is incorrect, option 3 is incorrect. The options, remaining options are 2 and 4. So we have to find out of 2 and 4 which is the correct option. Okay, now we have to find out the total spin. So for spin also, what is the value of S1? Okay, there are two unpaired electrons. So S1 is half, that is for the S orbital. For the P orbital also there is one electron, so the spin is half. Okay, so how do you calculate the total spin? Capital S, again the same similar formula, S1 minus S2 to S1 plus S2. Okay, mod means there will be no negative sign. So half minus half to half plus half. Half minus half is 0 to half plus half is 1. So there are two values of S, that is 0 and 1. Okay, so now what all we have got, L is equal to 0. Okay, and possible values of total spin is 0, 1. Now how do you calculate the value of J? It is L minus S to L plus S. Okay, now there will be two cases. One will be, let's say L is equal to 0 and S is, let's say, 0. And other case will be L is equal to 0, S is equal to, sorry, the value of L we have found out is what? It is not 0, it is 1. Okay, this is 1. So L is equal to 1, S is equal to 0. Second case will be L is 1 and S will be 1. Okay, so let us find out L minus S, that is 1 minus 0 to 1 plus 0. So this will be 1 minus 0 is 1 to 1 plus 0 is 1. So J value is 1. Okay, so for this we can write down the term symbol. That will be, okay, this will remain P. What is the total spin? Okay, S is equal to 0. S is equal to 0. So 2 into 0. How do you find out the spin multiplicity? 2s plus 1. 2 into total spin plus 1. Here S value is 0. So 2 into 0, 0 plus 1. So that will be 1. And what is the value of corresponding value of J? It is 1. So one term symbol is 1p1. Okay, from this only you can eliminate option 2. You can see here it is 1p0. Here it is 1p0. So this is incorrect. This is the correct option. So let us find out the other three values. Okay, for L is equal to 1 and S is equal to 1, J will be L minus S. So 1 minus 1, 2, 1 plus 1. So this will be 0 to 2. So J value is 0, comma 1, comma 2. So now there will be three terms. Here all are P. What will be the spleen multiplicity? This is 1. Okay, so 2 into 1 plus 1. 2 into 1 is 2, 2 plus 1 is 3. So all will have the spin multiplicity of 3, and there are three possible values of J. So I write 0, 1 and 2. So you can check, we have got all the four terms. One is this and the remaining three. So what is the correct answer for this question? Okay, the correct answer here will be option 4. Okay, now let us see this question. The ground state term and the calculated magnetic moment for dy3 plus ion is, this is dysprosium. Okay, so what is the electronic configuration of dy3 plus? It is, the electronic configuration is xenon 4f10 6s2. Okay, this is for dysprosium. We want dysprosium 3 plus. So it will be, we have to remove 3 electron. We will remove 2 from 6s and 1 from 4f. So it will be Xe xenon 4f9 and 6s0. So we have got 4f9. Okay, so f9. For this, for calculating the ground state term, we have to again calculate the value of L, S and J. Okay, f9, how do you fill the electronic configuration? F has how many orbitals? Suborbitals 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Okay, so this will be plus 3, plus 2, plus 1, 0, minus 1, minus 2, minus 3. Okay, we have to fill 9 electrons. So how do you fill 9 electrons? 1, 2, 3, 4, 5, 6, 7. All are singly filled. Then you do the pairing 8 and 9. Okay, how to find out the total L value? Okay, this value, that is plus 3 into total electrons are 2, plus 2 into electrons are 2, plus 1 into 1 electron. Then 0 into 1 is 0. Okay, minus 1 into 1 is minus 1, minus 2 into 1 is minus 2, minus 3 into 1 is minus 3. So this will be 3 plus 2, 6, 6 plus 4, 1, 1 plus, okay, 6 plus 4 plus 1 into 1 is 1, minus 1, minus 2, minus 3. 6 plus 4, 10 plus 1, 11, 11 minus 6, 11 minus 6 is 5. Okay, so we have got L values 5. Okay, L values and the ground state term. Okay, this is 0, 1, 2, 3, 4, 5 and 6. So if it is 0, it is S, then P, if it is 2, it is D, S, P, D, F, G, H and I. Now you can see for the L value of 5, what is the ground state term? It is H. So in all the options you can see it is H. Okay, so ground state term is H. Then what else we have to find out? We have found out L. Now we have to find out the value of spin. Okay, for one electron, the spin is half. Total there are how many unpaired electrons? Here you can see 1, 2, 3, 4, 5 unpaired electrons. So this will be 5 into 2. S will be 5 into 2, that is 5 by 2. We want to find out the spin multiplicity. Spin multiplicity is 2s plus 1. Okay, we saw the formula just now. 2 into s is 5 by 2 plus 1. So 5 plus 1, that is 6. So here there will be 6. Spin multiplicity is 6. In all the options it is 6. So let us find out the value of j. Now j can have two values. It can have L minus s, mod of L minus s, or L plus s. L minus s if it is less than half filled. Okay, less than half filled. That is here, total there are 7 orbitals. So F can have maximum of 40. So half will be 7. So if it is less than 7, it will be L minus s. And if it is greater than half filled, that is 7, formula will be L plus s. So here we know it is 9. 9 electrons is what? It is greater than half filled. So we will use the formula L plus s. What is the value of L? 5 plus total spin is 5 by 2. Okay, cross multiply. 2 5 are 10 plus 5, 15 by 2. Now you can see here there is 5 by 2, 5 by 2. So 3 and 4 are eliminated. We can have either option 1 or 2. Okay, now we have to find out the magnetic moment. It is a lengthy process. So there is one shortcut. We know that here there are how many? 5 unpaired electrons. Okay, so if it was a d orbital, we know whatever is the number of unpaired electrons, the exact value is slightly higher than that. If it is 5, then it is 5.9. If it is 3 unpaired electron, then it is 3.7 approx. Okay, so here, if you mark the option 1, then it will be incorrect. Okay, option 1 will be incorrect because if it is an f orbital. And in f block elements, we know there is orbital contribution of magnetic moment. Okay, so because of the orbital contribution, the value will be greater than 5.9. So straight away you can mark the answer as 2. Now what we have to do is we have to find out the value of magnetic moment. Okay, so that we can do now. Okay, so again what we need is we need the values of L. L is 5. Value of S. S is 5 by 2. This I can write it as 2.5. Okay, and J value is how much? J value is 15 by 2, that I can write it as 7.5. Okay, for easier calculations I have written it in fraction. So what is the formula for magnetic moment? It is G into root of J into J plus 1. Okay, what is the value of G? G is 3 by 2 plus, okay, how to remember the formula? There is, if I write in alphabetical order, I have J, then I have L, and then I have S. So start from the bottom, that is denominator. Here it would be 2J into J plus 1. Then right here, okay, after J it comes L. L into L plus 1. Then you have to remember here there is a negative sign. Then there will be S into S plus 1. Okay, so this way you can remember this formula of G. Okay, so now substitute all the values. Value of S is 2.5. So 2.5 into 2.5 plus 1, that is 3.5, minus L value is 5. So 5 into 5 plus 1 is 6, divided by 2 into value of J is 7.5 into 7.5 plus 1, that is 8.5. You solve this, the value of G comes out to be, okay, the value of G is 1.33. Okay, we have got the value of G. Now we can find out the magnetic moment. 1.33 into root of J is 7.5 into J plus 1 is 8.5. That is, okay, if you solve this, the answer comes out to be 10.62 Bohr magneton. Okay, so which is the closest answer that we have already found out? The answer will be 10.65. Okay, so the correct answer is option 2. Now let us see the next one. Based on the given data, the first order rate constant of the following reaction, okay, the correct statement is. So you can see this is the reactant and this is the product. How do you get the product? Okay, this is TFA, trifluoroacetic acid. What this will do? CF3COOH. This will give H plus ion. Okay, CF3COO minus. Okay, this will give H plus ion. So first step will be formation of a stable carbocation like this. Okay, so now there are how many options? There are three options for the value of X. So let us draw all the three options. One is hydrogen, second is fluorine, third is chlorine. We know halogens have three lone pairs. So let us draw them. Okay, now let us see the option. F and Cl inductively stabilize the intermediate carbocation. This is incorrect. Okay, because here we know that the carbocation is electron deficient, and fluorine or chlorine, they are also what? Electron withdrawing. That is, they are electronegative. So they will not stabilize the carbocation by inductive effect. Okay, they will stabilize by what? They will stabilize by mesomeric effect. Okay, like this. Second option, Cl stabilizes the intermediate carbocation better than H. Okay, so let us see the value of K, that is, we can say rate. Okay, we know rate is directly proportional to K. Then K, that is, the rate is also directly proportional to the stability of the carbocation. Okay, so the one that has the highest value of K, that will be most stable. So the one there is fluorine, that is going to be the most stable carbocation, and then it will be, so first will be fluorine, then it will be 4.81, that is chlorine, then last will be hydrogen. Okay, so second one is Cl stabilizes the intermediate carbocation better than H. Cl stabilizes the intermediate carbocation better than H. Okay, so I've written incorrect. After fluorine, there is hydrogen, and then there is chlorine. Chlorine value is minimum 1.7. Okay, 340, then 4.81, then this. Okay. So chlorine stabilizes intermediate better than hydrogen? No. If you see the order, it is hydrogen that is stabilizing the carbocation better than chlorine. So second option is incorrect. Third option, Cl stabilizes the intermediate carbocation better than F. No, you can see the value of Cl is least. So this is also incorrect. The correct answer will be fluorine stabilizes the intermediate carbocation better than H. Now the question is, what is the reason for this order? Now if you see the size of fluorine, it is smaller as compared to size of chlorine. So if I put three lone pairs on a very small fluorine atom, so what will happen? It will become very unstable. There will be electronic repulsion. Because of the electronic repulsion, this will be donating maximum electron density. Okay, donating maximum electron density as compared to chlorine. Okay, although chlorine is less electronegative, fluorine will be stabilizing the electron, donating the more electron density. Okay, then there will be hydrogen, and last will be chlorine. Why chlorine is last? Because here the inductive effect will be dominant. So this will make the carbocation even more unstable. So this will be least stable. Okay, that is why the rate is minimum. Rate is maximum for fluorine. Okay, I hope you have understood this. The correct answer for this will be option 4. Next one, transition state was developed to explain the empirical Arrhenius equation for rate constant for a non-linear. This is important. For a non-linear transition state, the effective degree of vibrational degree of freedom. So normally, what is the formula for vibrational degrees of freedom? A vibrational degree of freedom. What is the formula? If it is a linear molecule, it is 3n minus 5. If it is a non-linear molecule, then it is 3n minus 6. So there are two reactants, let's say A and B. They are combining to form a higher energy state. This is called as a, this region is called as the activated complex. Okay, and the and the point where it has the highest energy, that is called as a transition state. Okay, that is called as a transition state. So this transition state is formed because of the, while formation of this transition state, what happens is one of the vibrational degree of freedom becomes loose. Okay, one of the vibrational degree of freedom is, it becomes loose. That means it is getting converted to translational degree of freedom. Translational degree of freedom. So what will be the new values? Okay, what will be the new values of degree of freedom? The new values is, for a linear molecule, it will be, okay, 3n minus 5 minus 1 and minus 1. So for linear, it will be 3n minus 6. Okay, and for non-linear transition state, this is for the transition state. For non-linear transition state, it will be 3n minus 7. Question it is given, it is non-linear. So the correct answer will be option 2. Okay, let us see the next one. Huckel's rule. According to the Huckel's rule, we have to find out the aromaticity. So we know, okay, we know what is the condition for the compound to be aromatic. Okay, it should be cyclic planar, there should be conjugation, and it should have 4n plus 2 pi electrons. If it is anti-aromatic, then it must have 4n pi electrons. N is what? N is any number. 0, 1, 2, 3, any. Okay, it is an integer. Now here if you see boron, you have to remember that boron always has an empty p orbital or vacant p orbital that can accept electrons. So this, we can consider this as a similar equivalent to a carbocation, because carbocation also has a empty p orbital. Okay, so here if you see, there are how many pi electrons? 2, 2, 4, 2, 6 plus 2, 8, 8 plus 2, 10. So if I put 4n plus 2, n is equal to 2, 4 2 is 8 plus 2, I will get 10 pi electrons. So is this aromatic? Yes, because it is following Huckel's rule. Okay, so this is aromatic. Here also there will be vacant p orbital and there is conjugation. Okay, if I draw, how the conjugation will be looking like this. This pi electrons will be donated into empty p orbital of this boron like this. So there is conjugation. Here also there is conjugation in the second molecule. Okay, like this. How many electrons are there? 2 plus 2, 4, 4 plus 2, 6 pi electrons. Okay, so again 4n plus 2, if I put n is equal to 1, I'll get the answer as 6. So this is also what? This is also aromatic. Correct answer is option 2, both are aromatic. Third one, the change in the entropy and the Gibbs free energy when there is reversible melting of ice. Okay, reversible melting of ice. So that is water in solid form, that is ice, is getting converted to water in liquid form, that is a liquid water. This is ice, this is water at 0 degrees Celsius. Okay, whenever there is an equilibrium that is present, what is the value of G? G is equal to 0. So either the option is 2 or option is 3. 1 and 4 are eliminated. Now, if you see any compound that is solid, okay, when it goes to a liquid form, what happens? The molecules go far away. That is the intermolecular distance increases. So what will happen? The entropy or randomness, what will happen to the entropy or randomness? The randomness will also increase. Okay, so what will happen? The delta S value will be greater than 0. Delta G is equal to 0. So the correct answer is option 2. Option 3 is incorrect. Okay, so the correct answer is option 2. Next one. Here, the question is, this is a reaction that is given. Okay, the nucleophile is cyanide. The question is whether this reaction is nucleophile addition followed by elimination. Okay, that is addition elimination. Okay, they are asking the mechanism. whether it is addition elimination or nucleophilic aromatic substitution. Okay, that is SNAR, nucleophilic aromatic substitution, or it is elimination. Elimination means there will be formation of carbocation, then nucleophile will be adding. That is which mechanism? SN1. In SN1, first there is elimination, formation of carbocation, and then there will be nucleophile that will be adding. And last one is bimolecular nucleophilic substitution, is nothing but SN2. So first what we have to do is we have to remove the leaving group, that is this is a good leaving group because electronegative atom having positive charge is unstable. So we will get this carbocation. Is this carbocation stable? Yes, it will be stabilized by resonance like this. Okay, since the carbocation is stable, okay, this will be like this. Okay, the resonance is present. Since the carbocation formed is what? It is stable. So it will follow which mechanism? SN1. If the carbocation is unstable, then it will be SN2. So here the correct answer will be option 3. That is SN1 mechanism. Third one, this is the molecule that is given. Okay, C double bond O. I have aldehyde, I can write like this. Here above the plane I have OH. Okay, this is 9 and this is 10. What we have to do, we have to find out whether it is R or S. Okay, let us first find out for 9. We have to assign the priority. Here it is carbon, carbon, carbon. Okay, and here also there is carbon. So we have to see the groups that are attached to it. So here there is 2 oxygen atoms for this carbonyl group, and then there is 1 carbon. For this carbon there is 2 oxygen and 1 hydrogen. For this carbon this is CH2. So there is hydrogen, hydrogen and carbon. And this one here we have carbon, carbon and oxygen. Okay, carbon, carbon, oxygen. So if I want to write down, I can write here. Okay. Here above the plane there is, okay, now we have to assign the priority. Here you can see there are 2 oxygen, 1 carbon, 2 oxygen, 1 hydrogen. Carbon has higher atomic number, so this will get first priority. Okay, so if I draw here, there will be first priority. Then this will get second. Now if you compare both these, here there is oxygen which has higher atomic number. So this will be, okay, this will be 2, this will be 3, and this will be, sorry, second one is the one on the wedge bond. Third one is, this is 3 and this will be 4. Okay, now fourth priority is in plane. So what we will do? We will do even changes. Okay, we will bring 4 and 2, we'll exchange 4 and 2, we will exchange 1 and 3. Okay, 4, 2, here we will have 3 and 1. Now 1, 2, 2, 2, 3, you can see it is counterclockwise, okay, anti-clockwise, so it should be S, but you can see fourth priority is on the wedge bond. So we change the answer from S to R. Okay, this we had already seen in the rules for writing RS nomenclature. You can see that video if you have not watched. So for 9 it is R. Okay, so the answer can be 1, 2, 1 or 2, 3 and 4 are incorrect. Okay, now let us find out for 10th. Okay, let me draw the molecule again. Okay, let me draw again here. Here we have C double bond OH, C double bond O. Here I have OH. Okay, so this is 10. So we have to assign the priority. Oxygen will get the first priority. Here we have carbon, CH2. Okay, same. So check the next carbon, CH2, CH2. This is also same, CH2, CH2. Here we have CH2, here we have this carbonyl. Okay. So if we see, this carbon is attached to 3 carbons. Okay, so this will get the second priority, because here if we see the primary atom had 2 hydrogen. Okay, here we have 3 carbons. So that is why this is getting second. And here there is carbonyl, oxygen has higher atomic number. So this will be 3 and this will be 4. Okay, so now let us see how we can assign the priorities. Okay, here we have fourth group, carbon. Okay, here we have, this is 1, this is 3, this is 4, this is 2. Okay, so we can exchange 4 and 1 and we can exchange 2 and 3. Why we are doing this? Because again the fourth priority group is in play. So this will be 1, fourth priority on the wedge. Here there is 2 and here there is 3. 1 to 2 to 3, it is what? It is clockwise. So it should be R, but fourth priority is above the plane. Okay, that is on the wedge bond. So the answer will change from R to S. So 9R and 10S. So which is the correct answer? Correct answer is option 1. Okay, this one. This is the fission reaction that is given. What we have to find out, atomic masses are given. We have to find out the energy. Okay, so first we must know the formula for the energy. Which energy they are talking about? Binding energy. Okay, binding energy is the energy that keeps the nucleons together. That is proton and neutron in the nucleus together. That energy is called as binding energy. So during fission, what will happen? Energy will be released. That will be equal to the binding energy. Formula is delta M into 931. Unit will be mega electron volt. Okay, so what is delta M? Delta M is mass defect. We have to find out the value of mass defect. This will be atomic masses of the reactants, okay, minus atomic masses of the products. This is the formula that you have to remember. This is similar to if you know the formula for bond energy in thermodynamics. Okay, bond energy also we calculate, that is reactant minus product. Okay, so reactant, what do we have? We have 1 uranium atom. So 1 into atomic mass of uranium is 235.0439 plus there is 1 neutron. So 1 into mass of neutron is 1.00867 minus we have 1 barium. So 1 into atomic mass of barium is 139.9106 plus krypton, it is 1 into 92.9313. Last one is important. There are 3 neutrons. So you will multiply 3 into the value of atomic mass of neutron is 1.00867. Okay, this value of 3 is important. If you don't add 3, then your answer will be incorrect. This, if you solve, the answer comes out to be 0.18466. Okay, so what will be the energy of binding energy value? Delta M 0.18466 into 931. The answer comes out to be 171.9 mega electron volt. This you can round off to 172 mega electron volt. So the correct answer is option 3. FCC, this is a very simple question, straightforward. FCC, there are 2 atoms, one is A, another is B. B occupying every corner. Contribution at the corner is 8. Into, in a cube there are how many corners? We know there are how many corners? 8 corners. So 1 by 8 into 8 is contribution is 1. So A1 and B occupy every face. There are how many faces? 6. Contribution is half. Half sphere into 6, that is 3. So A1, B3 is the correct answer. That is AB3. Next one here, this is also very straightforward question. Heat or light is given. Whenever heat or light is given and temperature is also given, remember it is a free radical mechanism. So where we will form a stable radical, what is the form? What is the stability of radical? Tertiary greater than secondary greater than primary greater than methyl. Okay, so all the option what you do, it is very simple. Remove Br, add a radical. Okay, remove Br and add a radical and check which radical is stable. This is secondary, this is secondary. This radical, if you see, this is what? This is tertiary. It is attached to 3 carbons, 2 methyl and 1 this propyl group. So this is tertiary. This, if you see here, radical will be formed here. This is primary. So which is most stable? Tertiary. So the correct answer is 3. Here, among the following reaction, deuterium primary kinetic isotope effect. Okay, primary kinetic isotope effect, that is, it is the effect that whenever the hydrogen is replaced by an isotope, the question is whether this change that we do, it will affect the rate of the reaction or not. Affect the rate of the reaction or not. That is a question. Okay, that is the meaning of primary kinetic. Kinetic means we are talking about the rate. Rate means how fast or slow the reaction will occur. Isotope effect, because we are replacing it with an isotope. What is the answer for this? We have to check whichever CH bond is mentioned, whether it is getting broken in the first step or not. Okay, whether it is getting broken in the first step or not. If it is getting broken in the first step or not, why I'm saying this? Because this is the rate determining step. Okay, this will determine the rate of the reaction. Okay, if it is broken, then it will show primary kinetic isotope effect. And if it does not break, it will not show the isotope effect. Okay, rate determining step. First reaction, for that we must understand the type of reaction. So here if you see, this is which reaction? This is sigmatropic reaction. 1, 2, 3, 1, 2, 3. How does this take place? 1 bond is broken. New bond is formed between 3 and 3. Okay, 3 and third carbon. And this will shift here. So you can see, is this bond getting broken? No. Okay, this CH bond that was mentioned, okay, that does not get broken in the first step. That is not getting broken in the first step. So this will not show kinetic isotope shift. Which bond is broken? Only one bond is broken in the sigmatropic reaction. Okay, rest is the rearrangement. Okay, B step, if you see, it is a electrocyclic reaction, right? Electrocyclic ring opening reaction. This is also a pericyclic reaction. Here also you can see this CH bond is not broken. So this is also incorrect. Last step is decarboxylation. And we know in decarboxylation what happens. Here there is CH2OH. Whenever there is decarboxylation, this OH bond will definitely break like this. Okay, then only we will get what? We will get carbon dioxide. That is removed. So the correct answer is only C. Only C, option 4. Next one. This is a Jablonski diagram. Okay, so first step is, we know when the electron transition take place from the S0, that is ground singlet, to any of the excited, this is what? This is absorption. Then this is what? This is internal collision. Okay, because of which there will be heat that will be released. Okay, no radiate. This is called as non-radiative transfer. Okay, there is no light that is emitted. That is why it is also called as non-radiative transfer. Now, when there is a change of spin, that is singlet to triplet, this is what this is called as inter-system crossing. This is inter-system crossing. So let us see option A. Internal conversion, no. This is internal conversion that I showed you just now. This is internal conversion. Okay, it is called as inter-system crossing. So either option 2 is correct or option 4 is correct. Now generally we know that from S1, that is the excited singlet, to ground state, when this transition takes place, this we know it is fluorescence. That is S1 to S0. Okay, that is spin is same. The condition for fluorescence is what? The spin should remain the same. Okay, so this is fluorescence. Now T2 to T1, you might think this is phosphorescence, but this is not phosphorescence. Here also spin is not getting changed from second triplet to first triplet. Here also there is same spin. So this is what? This is fluorescence. This is not phosphorescence. This is fluorescence. So the correct answer is option 4. And this last step from T1 to S0, that is when spin is changing. This is what? This is phosphorescence. Phosphorescence. The correct answer here is option 4. This here what we have to find out? We have to find out the standard deviation. So what is the formula for standard deviation? Formula for standard deviation is root of summation of xi minus x bar divided by n minus 1. Okay, what does all these stand for? I'll write here. Xi is the values that are given. Okay, values that are given. X bar is the mean. Okay, n is the total values that are given. Okay, here there will be square. Okay, mod of this and then square. Okay, then you have to do the summation. Summation means addition. Okay, so how do you find out? First write down the x. First let us find out the mean. What will be mean? Add all the values divided by 3. Okay, take the average. 15.67 plus 15.69 plus 16.03 divided by 3. So this comes out to be 15.8. This is the value of x bar. X bar is what? It is mean. Okay, write down the value of xi. It is 15.67, 15.69, 16.03. Now find out the value of xi minus x bar. Mod. Mod means there will be no negative values. So take 15.67 minus mean value is 15.80. Okay, take the mod. This comes out to be 0.13. For the second one, it is 0.11. For the third one, it is 0.23. Okay, this is xi minus x bar. Now what we have to do? We have to do square of this. Xi minus x bar square. This will be 0.0169, 0.0121. This will be 0.0529. Okay, now we have to do summation. Summation means add all these three values. Summation of xi minus x bar the whole square. This will be 0.0169 plus 0.0121 plus 0.0529. This comes out to be 0.0819. Now we can find out the standard deviation. Root of 0.0819. Total values are 3. So 3 minus 1. The final answer is 0.202. So the closest answer is what? Closest answer is option 4. 0.20. Here, the correct order of hydride affinity, hydride ion affinity. So hydride ion affinity, it is what? It is inversely proportional to stability of carbocation. Stability of carbocation. Why? Because if the carbocation is stable, it will not like to have H minus ion. Okay, it don't want H minus ion. If the carbocation is unstable, it is more reactive. Okay, if it is more reactive, it would like to have H minus ion. Okay, so this is inversely proportional. So if the stability is more, hydride ion affinity will be least. The correct order of stability will be, let us see here, 2 plus 2, 4 plus 2, 6. This is aromatic. Okay, so this is most stable. Then here this is tertiary, this is primary. We know tertiary is more stable. So A, B and C. This is the order of stability. So hydride ion affinity order will be reverse. C, B, A. If C, B, A, the correct answer is option 3. X, Y, Z are the 3 p block element in the second row. What we have in the second row? This is first row. Row means it is period. This is first period. Hydrogen, helium, lithium, beryllium, then boron, carbon, nitrogen, oxygen, fluorine and neon. So these are the electron affinity values. The minus 142 is what? It is oxygen. This is fluorine. This value is not given anywhere. So the closest what we can think is boron. Okay, carbon is minus 122. So this cannot be there. Nitrogen is positive. Okay, so the only value that I can think of is boron. Y has the highest first ionization energy. Y is what? Y is oxygen. X is boron. Y is oxygen. Z is fluorine. Y has the highest first ionization energy. No, that is incorrect. Which will have highest first ionization energy? It will be boron. Why? Because it has S2. Okay, boron will not be, Y will not be the highest. Highest will be this, fluorine. So first option is incorrect. Second option, X has the most number of p electrons. No. This is how much how many p electrons? P1. Okay, this is S2 P1. This is S2. This is S2 P4. This is S2 P5. Okay, we can write down the electronic configurations. Boron is 1s2, 2s2, 2p1. Oxygen 1s2, 2s2, 2p4. Fluorine is 1s2, 2s2, 2p5. So which has the most number of p electrons? It is Z. Okay, not X, it is Z. Second is incorrect. X has the highest proton affinity. No, highest proton affinity is of fluorine. We have to consider what? We have to consider the magnitude. Okay, this is electron affinity. They're talking about the proton affinity. Okay, so that is also highest for fluorine. Okay, so this is incorrect. Correct answer is Z. We know fluorine is the highest. It has the highest electronegativity. 37. Isoelectric point. How do you find out the isoelectric point? For a neutral ligand, alanine, it will be pK of NH2 group plus pK of COOH divided by 2. This will be 2.34 plus 9.68 divided by 2. It will be 6.01. Okay, for if it is an acidic amino acid, what will be the PI? pK of the one COOH group plus pK of another COOH group divided by 2. For basic amino acid, it is the average of two NH2 groups. That is the two basic groups, and divide by 2. This is for the basic amino acid. Here the answer is option 1. Which salt has the highest solubility product? Okay, so solubility product is directly proportional to the solubility. If KSP is more, solubility will be more. Now when we add in water, what happens to the halogens? Halogen interact and they show what? They show hydrogen bonding like this. Delta plus, delta minus. So which will show the strongest hydrogen bonding? Hydrogen bonding is directly proportional to the electronegativity. So the correct answer is fluorine. Fluorine is more electronegative. Its hydrogen bond will be the strongest, and hence since this interaction is strongest, it will be the most soluble. Okay, in this, these are two questions. You have to find out the hybridization. CH3 N double bond C double bond S. How do you find out the hybridization? We have to count the sigma bonds. So 1 and 2, and there is one lone pair. Here there is no resonance. How do you count the hybridization? How do you find out the hybridization? It is number of sigma bond plus lone pair not involved in resonance. So 2 plus 1, 3. So this will be sp2. So the geometry will be like this. H double bond C double bond S. So this is what? This is bent. But when we consider silicon instead of carbon, silicon has an empty d orbital. Okay, so what will happen is this lone pair will be in resonance, or this is called as what? This is called as back bonding. Okay, there will be back bonding. So while finding the hybridization, we will not count this lone pair. We will have only two sigma bonds, that is hybridization is sp. Sp we know geometry is linear. So answer is bent and linear. Option 1. This question, NMR inactive nucleus. For the nucleus to be NMR active, the number of protons or neutrons must be odd. Okay, so proton, here it is odd, this is active, and then in between these two, okay, we have to find out the number of neutron. That will be for magnesium, it will be 24 minus 12, this is 12, this is E1. Okay, so this will be NMR inactive. Correct answer is option 3. For silicon, if I find out the neutrons, it will be what? It will be 29 minus 14, that is 15. Okay, so this is odd. So this will be active. Correct answer is option 3. Any one should be odd. Okay, proton should be odd or neutron should be odd. So here we come to the end of this video. Thank you so much.